In this video, I'm going to show you how to visualize a confidence interval for multiple groups of a variable. So oftentimes if you're investigating, say, group differences, you might want to graphically show that along with other statistical analyses that you might do. So like, say, a t-test or something like that. So you might want to show group means along with confidence intervals before you show the statistics there. So what you'll see here is I have SPSS open and data already loaded. This is my district level data, so each line or row in our data set represents one school district. There are two states in this data set, so this shows school districts in New Jersey and then in New York for the year 2016. And so let's say that we're interested in comparing the size of the typical school district or size of the average school district in these two states. So we're going to use our state name variable here and this variable here, which shows student enrollment, to explore that. And so to graph the average size along with their the average size of districts in both states along with the confidence interval for those averages, what we're going to do is go over here to graphs, then scroll down to legacy dialogues, and then down here to error bar. And then that brings up this box right here. And so in this case, what we want to do is we want to leave this as simple. And then down here, we want to make sure that where it says data in chart R, we want to select summaries for groups of cases. Since we're going to ask SPSS to group all of the observations for New Jersey together and then group all of the observations for New York together. Then we just click define. And so that brings these options up, and I'm going to move these because what you'll see by default is everything is going to be empty. And again, feel free to resize this box as needed. I always like to make it larger so that you can read all of the variable names. But what we're going to do is find the variable that we want to show. So we want to show the average district enrollment. And so we have our variable enrollment. We move that over here where it says variable. And then where it says category axis. So this is how do we want to group that? So like for what groups do we want to show enrollment? And like we said at the beginning, we want to use state name. So I'm going to highlight state name and just move that over there. And then we can leave everything else as the default. So it's going to show confidence interval for the mean, which is what we want. And then it's going to show a 95% confidence interval for those, which again is what we want. Then we just click OK. And then we get a graph. And so what this shows is, so in New Jersey, you can see that the average school district is a little under 2,200 students, but then we see the lower bound of the confidence interval around that mean comes down here to, we can eyeball it to be about 1,900, and the upper bound of that confidence interval, goes up to almost 2,500. It looks like you would, to say this with more precision, you would actually just estimate the confidence interval and read it that way. But this way you can show the mean in New Jersey as well as its confidence interval relative to the mean for school districts in New York, along with its confidence interval. And one thing to keep in mind is, so this will show the mean and confidence interval for both of these, but be careful in making interpretations. And so you can compare the means with this. So this shows that the average school district in New Jersey is larger. But if you were going to compare them with, say, a t-test, then that's going to use the variation here shown by the confidence interval and the variation here shown by the confidence interval. But it might be tempting to see if these confidence intervals overlap and use that to gauge whether they're statistically significant. But be wary of doing that, because that can lead you astray. And I can say, because I've in another video we actually run a t-test and we see that the difference is statistically significant. So just be careful in how don't overinterpret what you see in these graphs. But it's still a helpful way to illustrate to an audience, what you're seeing in the data as you interpret it.